Hey guys, this is distance learning assignment number 4. Gonna go over just a few of the problems so that when you guys do it yourself, it shouldn't be too bad. We're looking at number 1, and this is actually all review from last week, just making sure that we kind of keep building up to it. As you can tell, I don't think any of this has been super challenging, but there are some parts that are going to be uh, sort of abstract, so I want to make sure the fundamental things are sound. So for number 1, if you take a look here, it's that same idea about an obtuse angle, and we're going through all the quadrants. And as you can see, for 109 degrees, you want to remind yourself that each quadrant is 90 degrees. So the answer here, if they want an angle in standard position, C's the choice, because in quadrant 1, you go 90 degrees from the x-axis to the y-axis, right? From here to here. And then by quadrant 2, you're going from 90 to 180. And then 180 to 270. And then 270 to 360. So that's quadrant 1, 2, 3, and 4. Now, standard position means that I want to go in a positive direction. So 109 degrees is bigger than 90, but less than 180. So you end up in quadrant 2 this way. If you were to go negative 109, it would be choice B. But obviously, it says 109, so that's incorrect. And choice A would be wrong because they're starting on the west side. So going that way is incorrect. So choice C is the answer. If you want to find the least positive coterminal angle, right? Coterminal means it also terminates here, but it's not 109 degrees, and it's also positive. So what you do is you take 109 and add 360, and then you end up at that same standard position. The greatest negative one, all you have to do is subtract 360. So you go this way. So negative 251, you end up in that same spot. So just add 360 or subtract 360 to get to your positive or negative in this case. Looking at example 3, it's negative. It's a that's going negative. So instead of going counterclockwise, you're going to go clockwise. Standard position would be that way. Now, if you want to get the least positive angle, that's coterminal, it makes sense to add 360 to that. So if you're here, add 360, you end up there again. And that'd be actually I'm wrong. If you go this way, you basically have 297 degrees, which gets you to the same place as negative 63. Similarly, negative 423 means that, hey, you know what? If I go negative 63 that way, if I go, if I want to get there, I can go another 360. So it's negative 63 and then another negative 360, which gets you negative 423. So really, again, from last week, you should have come up with the conclusion that to get that same position, you can add 360 or subtract 360. They all end up being the same. It's just understanding that, how it works within the 4 quadrants. And as you can see, no matter what, you end up in quadrant 4. Okay. Number 6 is building off of the idea that we're in these quadrants, but it's something simple, really, really simple. We're going to start combining these different concepts in a later section, but right now we're keeping it easy. So what if I had the coordinate 2, 2? So that'd be over here. Well, you can see choice A. If you're a coordinate 2, 2 and you have an angle drawn out, you end up with what you see in A, right? The idea here is that at some point, we're going to understand these coordinates and we're going to be able to relate it to the angle measure. Right now, we're going to keep it kind of separate. So if you take this, and as you can see, we can look at that as a right triangle. And we know that this is 2 and 2 because that coordinate is 2, 2. So let's look at that now. And this question wants to find the radius, the distance from the origin to the coordinate point 2, 2. So what would that hypotenuse be? What would that radius be? And so all that is just Pythagorean theorem. R squared equals 2 squared plus 2 squared. That'd be 8. That'd be square root of 8. You could break this down to 4 times 2. They're both still square roots of 4 and a square root of 2, but one of them has a square root of 4. So the square root of 4 becomes a regular 2, and the square root of 2 stays a square root of 2. If you forgot, you can also do this, right? And then you get 2 of these. So for every 2 you get 1 comes out, and then that 2 stays inside. And 2 root 2 is the radius, or you can say it's the hypotenuse of that triangle. Okay? Let's move on. Example 9. The coordinate is -4 root 2. So -4 and then root 2. So, whoops. So -4 this way and then root 2 that way. And root 2 is about 1.4. So that means that when I make my triangle, start here, go to -4, about a little more than halfway up. Okay, and that's my triangle there. You can see that you're in quadrant 2 because, well, negative x and a positive y, -4 and a positive root 2 means that you're in quadrant 2, right? Your y is positive and your x is negative. And now we need to do Pythagorean theorem again. So let's see, r squared equals -4 squared plus root 2 squared. Let me zoom in a little bit. R squared equals, that's going to be 16 plus root 2 squared is just a 2. Okay, because root 2 times root 2 is root 4, and square root of 4 is 2. And you get r squared equals 18, which means r is equal to square root 18. And I can say square root of 18 is equal to 9 times square root of 9 times square root of 2. And then that will be 3 root 2. And again, that is your answer. So the distance from here, the origin, to the point that they gave us is 3 root 2. Last question. Looks like 9 and 10 are the same question here, so maybe you guys get the same thing, get the same answer. All right. Last question. It's a conversion. Pretty straightforward, this one. 35 revolutions per minute. How many revolutions per second? So it's a unit conversion, and it's only one conversion that we need to do. 35 revolutions per minute. Per means division. So I'm going to say divided by 1 minute. Means for every 35 revolutions, 1 minute passes. I need to convert this. So I'm going to multiply. Oh, why am I not writing here? Okay, there we go. So if I don't want minutes, I want the minutes to cancel out. So I'm going to put minutes on top. I want to convert minutes to seconds. So I don't want the minute unit there anymore. I want seconds. So if I put 1 minute on top, that's going to allow me to cancel out. But I can't just multiply by 1 minute because, well, then I'm just changing the value. So 1 minute is the same thing as 60 seconds. That's the unit that I want. And remember, 1 minute divided by 60 seconds, that's actually 1. We're actually just multiplying by 1. It's in a different unit. So let's go ahead and do that. And that's basically 35 revolutions per 60 seconds. And if I just reduce that, I get 7 over 12 by dividing top and bottom, reducing the numerator and denominator by 5. I get 7 over 12 revolutions. Actually, I'll write this. Revolutions over seconds, which is what they're saying over here, right? Because per means divide. And that's it. Hopefully, these fundamental concepts will be pretty straightforward, pretty solid in your mind, because we're going to get into some things that start putting all of this together. All right. Stay safe and well, guys. I'll catch you guys soon.